Welcome everyone to the deploy talk. We're going to talk about installing, upgrading, and scaling. This talk comes after two previous talks that you may have attended this morning. One was design, how to model your data for just data, and also for security. And then the talk after that was developing, how to implement what you modeled into your app. And in this talk, we're going to take the server-side components we developed this morning and then deploy them. A quick reminder about our Connect app. It's available on the App Store and the Google Play Store, and the QR code is, of course, here. So if you haven't got it, it's your chance to get it now. But I'll show that slide at the end again. And also, if you could spare a few minutes to take the survey in the app, that would be very appreciated. Okay. My name is James. I'm a technical writer at Couchbase. And this is my attempt at building a standing desk, which kind of failed. But it's also going to be in line with what I'm going to present, which is the sort of long way of doing things. And it's a bit clunky and it's a bit hard. And yeah. And with me today, Traun Leyden, who is a software engineer at Couchbase on the Syn Gateway team. And in this talk, we're going to basically take different approaches to deploying the same architecture. First, we'll talk about what the architecture is. And then we'll talk about virtual machines, a way to deploy them on virtual machines. And then Traun will take over and talk about containers, how to deploy it on containers, the same architecture. He'll demo that using Docker Cloud, but there are other platform as a service providers. And after that, we'll combine the two. And if that works, then it'll be the demo god day. So the system overview is 3 layers usually. There's the Couchbase server layer, which is the persistence. This is where data gets persisted, always, in production. And the recommended number of nodes when you deploy Couchbase server in production is usually 3 nodes. Then in front of this, if you're developing an app with Couchbase Mobile, comes Syn Gateway. Usually you can start with 2 nodes to have resiliency. And those nodes, they are stateless, so they don't persist any data. They sort of proxy it. They keep all the connected clients in sync. They apply your security rules, but they then persist all the data in Couchbase server itself. And the load balancer in front of it will just distribute the load, like on different systems. That's a common pattern. And you may not see it, but I just want to mention, if you haven't been in the talk this morning, there is also a Couchbase Lite database running on the device itself, right here. Oh, you can't see it. That's a shame. I'm zooming in, but you can't see it. OK. Well, you can take me for. So yeah, you can see it. It's on the. It's very small, tiny. Yeah. All right. The first way to deploy this architecture will be on virtual machines. And there are different platforms we support, such as CentOS, Ubuntu, Red Hat, Windows, and OS X. And depending on the one you choose, you usually have those 4 steps to go through. First, you start the virtual machines. Then you provision your Couchbase server and Syn Gateway nodes on those machines. Then you configure those nodes for your application. That's like, for example, the database name, the sync function, webhooks, all sorts of application-specific configuration. And then if you have an increased load at some point, then you may want to scale them. But that 4th point could come at a later point in time. OK, I'm going to switch now to my laptop, and I'm going to show you. That's what I ran before. Oh, that's a shame. Okay, little glitch here. That's what I ran before starting this demo. I ran Vagrant up, which started 5 VMs on my local machine. And here's the table that maps what each VM is going to do. So we have 1 Couchbase server, 2 Syn gateways, 1 Nginx. And if we wanted to scale, we just got a third Syn gateway. Note here that we have only 1 Couchbase server instance. That's because we didn't want to end up with 7 virtual machines, but in a production environment, you'd have 3 Couchbase server nodes at the top there. And I've sort of split up the terminal windows to try and show that here on the left, you've got Couchbase server, on the right, sorry. And then in the middle, you've got Syn gateway 1 and then Syn gateway 2. And at the front, you've got the load balancer. And there are already a bunch of scripts on those VMs. Those scripts are part of the training, which you can access at any time. And so you can have access to those scripts as well. I'll explain what they do as I use them. The first one is to install Couchbase server. So this one will install the software, initialize Couchbase server, create a user, and then create a bucket. The bucket is where the Syn gateway nodes will persist data to. Okay, so now it's done. I can try to log in. The user was created as part of the install script. And in the data buckets, I see there's one to do, but there are no documents in there yet. You could obviously create the node using the UI. It doesn't have to be using the script. So that's what Traun will do in his demo. Okay, the second thing to deploy now is Syn gateway. In this one, we're going to use install Syn gateway. And we have to specify which Couchbase server node to connect to. So usually, you would open your config file, replace the server property with the IP of the Couchbase server you want it to connect to. But this script sort of automates that process. So when you call the script, you have to specify which IP you want to, the IP of the Couchbase server node. So this one is 34.11. If we go back to this table here, we see that .11 is Couchbase server.
So do we have to list all the Couchbase? Let's say for 3 instances then?
No, we don't have to. All right, so that's started. Now, if we go to 192.12 at the end there, we should see that Syn gateway is running, 1.3.0, right here. I'll repeat the same step for Syn gateway 2. And now I can just switch to 13 to make sure it's running, yes. And then for the load balancer, it has to start, but it has to load we have to specify 2 IPs this time, the IP of Syn gateway 1 and Syn gateway 2. So the script in this case is called configure nginx. Syn gateway 1 is .12, and Syn gateway 2 is .13. Now I see that on the Nginx node, which is 192.168.34.14, actually Nginx is not running on port 4984, it's running on port 8000. So I'll see that now I still obviously see the same response from Syn gateway, but it's going through Nginx. And I just realized I wanted to install a different version of SYNC-Gateway on the second node to show you how it just switches between the two different ones. So what I'll do real quick here is actually uninstall it from the second node. Yeah, nice. So this script is slightly different. It's called install latest SYNC-Gateway. So it just downloads the 1.3.1 version. Okay, now that's installed. You see now that this version switches between 1.3.0 and 1.3.1. That means that, our proxy is balancing the traffic across both instances. Now you've got this up and running. You've got your app developed. It's time to connect the two sides. So we have the application of the training here. The training is available on the Couchbase Mobile documentation. And on the landing page of the training, you see that this is the app. It's a to-do app. And here I've enabled login, I've enabled sync, and I've put 34.14 as the URL it's going to point to, which is the Nginx node on port 8000. If I log in as user 1 and pass, there are no documents. And what I'm going to do now is create a list from the command line, which is a list in the name of user 1, and the password is pass, pointing to the Nginx node on port 8000. And the owner is user 1, the name is connect16, and the ID is user1.123. I could create it from the app, but actually I need this ID because then I want to continuously add some tasks using the REST API of SYNC-Gateway, the REST API. And then while this is happening, I'll see that they get replicated and take one node down of SYNC-Gateway and see how it still works, because we have one node that's up. So I'll create that, and then the app should display this. And then I'll run that script, which will create a new task every 2 or 3 seconds. And this count increments because the tasks are created, and this count is the number of uncompleted tasks in that list. So remember, we put Nginx as the URL in the endpoint, the Nginx node here. So I should be able to take one SYNC-Gateway node down and still be able to see the documents replicated to the mobile device client. I'm going to take down the 1.3.0 version. For example, imagine if you were doing a version upgrade, that's the one you would take down. And now we see that on the browser, instead of returning 130 or 131, it's always going to return 131. That means, one node's down. Nginx obviously can't forward the traffic to that one. And the app should still be receiving some tasks. And it does, so the counter increments. That means that our app server, which is sending documents to the Nginx node, is proxying to the SYNC-Gateway node that is up. And in turn, our app is then pulling those tasks down. So this process of taking a node down, you could apply it to version upgrades, but also, and maybe more frequently, to configuration changes or just general maintenance. As I said, all those scripts are available on the documentation, and that's kind of the list of the different scripts. There's also one for scaling or reconfiguring Nginx, but all those scripts had to be sort of customized for the platform, and also maintained in a way. So that introduces, that makes a good segment for the next way of deploying this architecture we saw at the beginning, which is using containers. And I'll pass it on to Traun, who will continue the talk.
Okay, I'm going to talk about the new hotness here. This is probably bordering on production ready, but next year it will probably be closer, and the year after that it will probably be the norm. So we're going to talk about containers. Just to get a list of hands, who here is, let's say, really has no idea what containers are? They're just totally baffled, like doesn't know the difference between containers, virtual machine. Any others? No. Okay, so we're all pretty good on containers, so I won't go too deep into that. So we're going to talk about Docker today. That's not the only container game in town, but there's other ones. CoreOS Rocket and Red Hat is now coming out with its own container platform. So we're going to, for today, just stick to Docker terminology. So the advantages of containers is basically they're very quick to start and restart. They're very portable. So the whole idea behind Docker and the whole shipping container analogy was because the folks at Docker realized, why is it so hard to move a web application from one cloud or one private data center to another? Why isn't it just like more pluggable? And so what they saw that was missing was a very common standard interface like you have in the shipping container world. That the dream is you can just easily migrate. You can have one application that can actually either migrate to another cloud easily or just straddle those two clouds. So that's still in the making, in the sense that these containers as a service providers are still slightly different. The other thing you get is, and the same thing you get with virtual machines, is isolation. So anything in a container can't access or affect anything in another container, in theory. I'm sure there's people out there who are poking holes in this or trying to, because all these containers are running on the same operating system, at the same kernel, rather than virtual machines. They run on a abstracted operating system. You can also get really fine-grained resource allocation and scheduling, where you can say this container has access to this many CPUs and so forth. This is another thing you get with virtual machines. But there's some challenges that come along with this. So you get this sort of microservice overhead, in the sense that Docker is very opinionated on how you should run containers, and it's kind of like one process or microservice per container. So it doesn't like you to run upstart or systemd and have all these background services, which is probably how most people normally deploy. So if you want to follow the idiomatic Docker container approach, you're going to be breaking stuff into microservices. And a lot of people want to do that anyway for other reasons. So that may or may not be something that you welcome. There's a lot of challenges around persistent data. Basically, the containers are great for stateless web server, load balancer kind of stuff. You start to get into challenges when you want to store persistent data. For example, their native file system is based on Union FS, and it's not really appropriate for high I/O. So you kind of want to mount a volume, which means you're essentially you mount a volume into the directory of the container, which is kind of like a pass-through. So all your data doesn't get written on the container itself, it gets written on the host. And that's a lot faster because you're not going through this Union FS. And when you stop the container, your data is going to persist beyond that container instance. The data will still be there. The problem is, if in the sort of typical container orchestration platform like Kubernetes or Docker Swarm, it doesn't necessarily take these things into account because it just wants to move your containers around like fluidly. But it has to know that it has to take the volume with it. And if that volume has a lot of data, that's actually a difficult operation or a time-consuming operation. So they're just starting to add this into the Docker ecosystem. There's something called pet sets from Kubernetes, which has been introduced to solve this issue. And the reason it's called pet sets is because there's a saying that you should not treat your containers as pets with some individuality. You should treat them as like cattle, like these generic. Or you could say, if robots versus unicorns. So the idea is that these if you treat them like cattle, you can just replace them and they're not unique. But if you're talking about persistent volumes, you have to treat them especially like as pets. You have to think about, this is going to migrate. We have to take the data with it. The other challenge with container is networking. So if you have containers across different hosts and you run in the sort of default networking mode, those things can't actually talk to each other. If you have a single host and the containers, they have a route to each other, but not across multiple hosts by default. So the right way to solve that is to use something called overlay networking, which essentially it adds that for you. You probably don't want to do this at home. There's something called Weave. It's really hard to set this up. If you want overlay networking, you're probably better off using something like Kubernetes, which gives you Weave networking for free, or something like Docker Swarm or Docker Cloud, which I think it might use Docker Swarm under the hood. But in that case, it's transparent. You don't have to think about the networking between containers across hosts. They just all have their own IP, and there's routes between the two. Couchbase Server can be a little bit sensitive to this because you kind of bake in the IP address, or you can bake in the IP address. You have to give it like a host or an IP. And if that changes from under Couchbase Server's feet, it won't start. It's unhappy. It detects the difference, and it just throws its hands up. And containers are typically very ephemeral, and they might get a new IP address. So the workaround for that is to use stable, routable DNS names that won't change. But you have to make sure that that the container can bind to that host name and not blow up. So one cool thing about containers is you get these cool platform as a service providers along with them. We enable that with our official Couchbase images on Docker Hub. We've got a small dedicated team at Couchbase that we are maintaining and testing these containers now. So I'm showing the Couchbase server and Couchbase Sync Gateway container web pages on Docker Hub. And if you just want to play with this locally, for example, I don't have a slide, but you can just kind of run Docker run and then this container name. And if you have Docker installed, you can actually spin up a really large cluster very efficiently on your workstation. That's another advantage. Is if you try to run, well, James was just talking about he couldn't run 3 Couchbase server nodes because it was just going to kill his machine with all these virtual machines. With containers, you can, because it's literally it's on the same operating system. So yeah, let's talk a little bit about the platform as a service providers out there. So I'm talking a lot about containers, but I don't want to pigeonhole into that because there's a lot of IaaS and PaaS providers out there that Couchbase supports and you can deploy on. So we have AMI images on AWS that we build as part of our build process, and we test as well. And those are basically virtual machines on AWS that have the software pre-installed. And we do the same with Azure. I don't know if we have Google Compute Engine, GCE, on here. I know we run on there, but I don't know if we provide pre-baked images. We've got Docker Cloud support, and we are working on OpenStack 3 support. It's worth noting that this is Red Hat OpenStack 3. It's worth noting that Red Hat OpenStack 3 and Google Container Engine both use the Kubernetes orchestration platform, which is from Google, and it's open source, and it's essentially the next generation of their Borg container scheduler. So Google's kind of been the pioneer in a lot of this stuff. They've been doing this stuff for like 10 years before Docker kind of came and repackaged it and made it really nice. But they've been running containers, and they have the Google Container Engine available. So I'm going to give a demo of Docker Cloud, running Couchbase Server on Docker Cloud, and we're going to provision nodes. So on this slide, you can see that there's 2 nodes. This is the orange boxes, and those are like the quote-unquote physical hardware instances. In this case, it's virtual machines running on EC2. You have a concept of services, and that's what these dotted boxes are. And so a service on Docker Cloud is essentially a group of containers that all runs the same Docker image. So they're running the exact same file system, identical file systems, and identical software is installed. And they're grouped because, for example, if you look at the HA proxy service, that thing, you point it to the sync gateway service, and it knows how to reach any of the containers in that service. Another way you could run this, which might be a little more in production mode, is to essentially have a kind of a one-to-one mapping between your containers and your physical / virtual machines, because Couchbase Server, and it wants all the hardware. So it's usually never recommended to run anything on a machine next to Couchbase Server. And Sync Gateway, there's not really a lot of value out of running multiple on the same instance, but there is some advantages in the sense that, you could still kind of get away with, if you have this and you can dedicate most of the hardware to these Sync Gateway service instances, you could kind of sneak in like a parallel test cluster. I don't have a diagram for that, but you could kind of sneak in some other containers and tell them not to use very many resources, and everything else would just stay the same. Okay, so we go through a demo here. Let's see. How do I switch it over? Unplug this and back in. Okay.
Can I ask you a quick question about the Docker service that you had there?
Let me take questions at the end,
Okay, all right, thanks.
but I will make sure to leave time for that. Okay, so can everyone see that? Okay, so we're on the Docker Cloud Web Interface here. So I have pre-created 2 nodes, which going back to the diagram was the physical instances. These are running on AWS. I should note that you can link, it's pretty slick, you can link Docker Cloud instances on various providers. So you see their pick lists. You can actually, it's like bring your own cloud style. So you can link it to Microsoft Azure, DigitalOcean, SoftLayer, and Packet. And so these nodes are actually running in the Couchbase Mobile AWS account. I've defined, also it's worth noting that this little box here with the 0 is basically saying that there's 0 containers running on either of these nodes. So I've predefined these 3 different services, which correspond to the diagram with the 3 dotted boxes. Couchbase Server, Sync Gateway, and SG Load Balancer. So I'm going to create I'll create I'll create a 2-node cluster of Couchbase Server. Basically, it's going to create 2 containers, and it's going to spread those out evenly across the available nodes. And while that's kind of scaling up, I will show. Oh, it won't let me, unfortunately. I was going to try to show you the config here, but it looks like it's blocked while it's editing this. Let's see if there's anything. Oh, actually, so here it shows some of the parameters that were used. So this is the image tag. This is the same. This is the name of the image on Docker Hub, and this sort of latest is basically telling it to use the latest deploy or the latest version of this container. If you had to run like Couchbase Server 4.0, then you would add that in the tag. The high availability deployment strategy is basically telling it to spread the nodes as far apart, or spread the containers, like don't put the same containers in the same node. That's basically what it's saying, is within limits. And then there's all these, unfortunately, Couchbase Server has quite a long list of ports that you have to expose, and that's part of the config. So, so it says it's running, so I've got these 2 containers running, and I'm going to arbitrarily pick one here, and we're going to go to the admin UI, and it's not configured, so we're going to go ahead and configure it. The kind of weird, tricky part here with Docker Cloud is that you give it the container IP. I'm not going to get into this. If you want to ask me more, or if you ever do this, you can get in touch with me to ask me more questions. So, so yeah, I'm starting a new cluster. I'm just going to leave everything as the defaults. It's a little slow. I'm not running on extremely powerful hardware here. So I'm going to skip the bucket creation and skip the registration. Okay, so we've got Couchbase Server running, and I'm going to create a to-do bucket. Okay, so I'm going to skip this for now, but I could basically provision another Couchbase server and have it join this cluster, but just for time reasons, I'm just going to keep a single node. So I'm going to go ahead and start a sync gateway, or I'm going to scale up this sync gateway service to 2 nodes. And noteworthy parameters here is, likewise, I'm giving an image name. This time it's Couchbase/sync gateway, and that's the image on Docker Hub. I'm giving it this, it's not letting me copy and paste. This URL is the only parameter to sync gateway. Sync gateway, usually when you start it, you give a configuration. It's either a JSON file in the file system, or you can just give it a URL with the JSON content. So I made a GitHub gist and put the sync gateway configuration in that gist, which is just like a paste bin thing. And so when sync gateway starts up, it's going to pull that URL configuration and use that. The other thing that's noteworthy is that this container can now talk to Couchbase Server. I don't have to give it it doesn't have to know the IP of Couchbase Server. You can just give it a host name of Couchbase Server, and that will, thanks. And it will resolve that to the container IP. So real quick, I'm going to show you the, here's the sync gateway configuration. So here, and this is what links the 2 services. So I just tell it to talk to Couchbase Server -1, which is going to be the first container I started for Couchbase Server. So let's take a look and see if this thing is running here. So go to sync gateway 1, and I'll copy and paste that URL and go to 4984. Okay, sync gateway is running. And now the last service I'm going to start up is SG Load Balancer, which is HA proxy, which Docker Cloud just gives that to you. All you have to do is just you just link it to the service that you want to load balance across. And so if I go to this edit thing, you can see that right here under links, I'm linking it to the Sync Gateway service. And it's pretty smart in the sense that I didn't even have to tell it what port to load balance because it knows the port configuration of that service. So, so at this point, I should be able to go to the load balancer. And this is running on port 80. And now you can see it's load balancing the Sync Gateway. I have both 131 instances, so I can't do that neat little trick where I reload and see the different versions. So we're going to try to squeeze in one last aspect of this demo. We're going to try to synchronize the data from the cluster that James created to the this Docker Cloud cluster. So if you want to come up here. So here is, and then just do /to-do. So while he's doing that, the component we're going to try to use is called SG Replicate, and what it does is it just shuttles data back between. It shuttles data across two sync gateways. So it uses the Sync Gateway REST API, and it can run. We're actually going to run it from it runs in push mode or pull mode. So what we're going to try to set up is to have it push from his Sync Gateway up to the publicly accessible Docker Cloud. We couldn't do the other way. We couldn't push from Docker Cloud down to his Sync Gateway because his Sync Gateway is behind a firewall and so forth. But the SG Replicate is bidirectional, and you can run either the push or the pull or both. In this case, we're just going to run it unidirectional, just a push. So what he's doing now is essentially adding this configuration to Sync Gateway. The source means where it's getting the data from. In this case, is a local database called to-do, and the target is where it's going to be pushing to. You'll notice that there's no parameter like push or pull because it's implicit. It's always pushing. It's always moving from source to target. So if you wanted to do a pull, you would kind of just reverse those two. So if you want to do a pull, the source would be the remote database, and the target would be the local database. We also have another parameter, continuous, which is a Boolean. So this is the most common way to run it, where it runs asynchronously within Sync Gateway in its own kind of Go routine /thread, where it's constantly, anytime there's new changes to the Sync Gateway, it's going to be synchronizing them. But you can also run it in one-shot mode, which instead of running the background, it tries to do the push or the pull, and then it just stops. And that's kind of useful for debugging, or in the case that you're not running full time. Is it user one and pass? What? Oh, mod. Sorry, guys. This is a demo that we try to put together. This is going to be icing on the cake if this works, but it's not working.
So there are no documents yet.
Oh, okay.
And now I'm going to restart Sync Gateway and see if the documents that were added via this script, and now we're at 700 tasks, were now replicated to the one on Docker Cloud.
Pull up this and give me logs. All right, try to hit reload. those logs.
What you doing up here? Yeah, that's fine.
So if you're not busy tonight and you want to come by the foosball table, we'll have this demo working by 8 p.m. Oh, we can take your question.
Yeah, so the one that I was going to ask, you actually answered. I was going to ask about, you mentioned how Docker service sort of knew where all the Docker instances were, and if that somehow just sort of automatically load balances. But then you talked about HA proxy just easily sitting on top of it. But another one was, do those create any problems with WebSockets or long poles with the replications back to the...
Yes, great point. So we actually have some documentation on how to configure Nginx so that WebSockets pass through. I think we're telling Nginx to basically to not freak out because it's just not expecting that. But we have in our documentation, if you want to talk to me afterwards, I can show you. We have Nginx configuration only. HA proxy would be a different set of configs, but that's definitely something to be aware of if you're enabling WebSockets. And for people who don't know why we're using WebSockets, we have a mode in Couchbase Lite to, when it connects up to Sync Gateway, to get the latest changes. You can, I think it defaults to HTTP long pole, but we also have a WebSockets mode. And that, it's very fast and it's very slick, but it does pose some challenges in terms of you have to make sure that any network device in between is going to not just close those or, yeah. That would be in the Nginx configuration. Like Nginx has, it's basically a file, and like we have an example on our docs. Yeah. So if you're deploying Nginx, you definitely want to look at those. It's a whole guide about how to deploy Nginx. And if you have other load balancers that you want to deploy, you can email us, and we can make guides for those other load balancers. Sorry, can you say that again?
Is the WebSocket supported on both Android and iOS?
I know for sure it's supported on iOS. I don't think it's supported on Android. And with HTTP2 that's come out, I don't know if we would I know HTTP2, H2, some people call it, has a little more bidirectional streaming properties. So yeah, I think currently it's iOS only.
So HTTP2 would be supported?
No, I just think we might be considering that rather than WebSockets, but don't quote me on it.
So on the UnionFS file system load you showed.
Wait, sorry, can you say that again?
In the Docker file system, it's using a UnionFS kind of mode, right? So in that,
Yeah.
on a resource one-to-one mapping on a container versus a system, like a pure hardware server, what's the performance degradation?
It could be huge. UnionFS was not designed. I mean, it was designed to be a layered file system. So, are you asking the degradation between UnionFS and ext4?
So the same deployment that you showed us.
Yeah.
If I were to use it one-to-one, like deploy it on a hardware server,
Okay.
versus deploy it on containers, what's the ratio that I should be considering in terms of my capacity support? Like if I could do like 500 TPS over here, what's the degradation in here using Dockers?
Oh, you mean kind of like the overall overhead of having it in a container? So theoretically, it should be very, very low in the sense that it should be much lower than virtual machines, for example, because in the virtual machine model, you have this translation of every CPU instruction. It's pretty heavyweight. In the Docker container model, it's essentially you're taking a Linux kernel, because it only natively runs on Linux. If you're running on OS 10 on your laptop, it actually spins up a Linux virtual machine. But the point is, there's no translation layer. So everything should be like just as fast as running on bare metal, in theory. But the file system can introduce bottlenecks, and those could be significant. So if you were doing some perf testing, you'd want to definitely use the volume mounts. And we are doing QE on Docker containers, and we've done some smoke test performance testing. We haven't noticed any major degradations. So if you want to talk to me afterwards, we can try to dig up those numbers together.
Yeah, I'd like to see some performance numbers if Couchbase has.
Yeah, okay.
Thank you.
Any last questions? I think we have to wrap up pretty soon. Cool. Okay, thank you so much for joining, and feel free to talk to us.